this question we're asked to solve this trig equation. It's got a sine 2x in it, there's a cos x in it. We're given the range of values that x can take. So let's go ahead and start this. We do know a formula for sine 2x. We know that sine 2x is 2 sine x cos x. So let's use this formula to replace sine 2x by 2 sine x cos x, and we'll have a look at the result, see what we can do further with this. Well, notice that there's a common factor of cos x, and while we're talking about common factors, there's also a common factor of 2 that can be taken out. So 2 cos x, and that leaves you with sine x in the first term, and 2 times 3 gives you the 6, and the cos x has disappeared. So here we have 2 times cos x times sine x plus 3 equals 0. So one of these terms in the product must be 0. It's certainly not 2. So either cos x is equal to 0 or sine x plus 3 is 0. Now this second possibility would lead to sine x being a value of -3. So we're hunting for an angle whose sine is -3. Let's remind ourselves of what the sine graph looks like. And that continues beyond the 0 to 360 degree cycle. Remember, it goes up to 1 and down to -1. Now, this equation would be asking us to find a value of x whose sine is -3. We're looking for a height in this graph of -3. So we're hunting for some angle where the graph goes down to about here. Well, we'd spend a long time hunting for such an angle. There is no such angle. The sine never goes below -1. 270 degrees sine of 270 degrees -1. It never goes below that. So hunting for an angle whose sine is -3 is a futile exercise. There is no solution. And it's important you rule that out. There is no solution for this equation. So we're left with cos x equals 0. And just a reminder of the cosine graph. There's your 360, it's back up to 1. But there and there, the cosine of this angle 90 and the cosine of this angle 270 have a value of 0. So this would imply that x equals 90 or 270. So solve this equation. This is the range of values of x from 0 to 360. So 90, 270. We can't go outside. We can't get the 450, which is down here, or the one away along here. They're out with the range of values that were asked for. So the solutions, valid solutions, are 90, 270. So that's part A. So let's now have a look at part B. We've got a very similar equation. In fact, we compare them. The angles in this second equation are double the angles in the first equation. So replace x by 2x to obtain the new equation. So having solved the old equation and found solutions 90 and 270 for x, these must now be the solutions for 2x in the new equations. So 2x must be equal to 90, 270, which in this case means x must be 45 or 135. But wait a minute, if we're halving values and yet the range for x is still 0 from 360, these further examples where cosine of x was 0, for instance, remember I mentioned this 450. If I have 450, then x is still within that range, and there'll be another one away along here, which is 360 added on to this 270. That's 630. So 90 halved 45, but if I add 360 to that, I get 450. That's in the next cycle. Halving that's 225. That'll be a perfectly valid solution. And then adding 360 to this 270 is 630. And halving that gives me 315, which still is less than 360. Now, there's no point in going another cycle because the next one on from that, if we add 360 to this and get 810, if I half 810, I would get 405, which is more than that 360. So I've achieved all the solutions between 0 and 360. There's now 4 of them. First 2 coming from the first cycle of the cosine curve, the second 2 coming from the second cycle of the cosine curve. And that's because I've found the angles 2x and have to half them to get the actual angles x. And you notice that this is not 0 less than or equal to 2x less than or 360. It's still x. So 4 solutions for that. That's Mr. Corsi signing out. Hope you enjoyed the video.